それでは時間となりましたので、セミナーを開始いたします。本日座長を務めますのは、九州大学アジア・オセアニア研究教育機構創発推進コーディネーターのキム・シューマッハ准教授です。シューマッハ先生、よろしくお願いいたします。
Thank you very much. And first of all, welcome everyone to the 121st Brownback seminar. It is my immense pleasure for this edition of the Brownback seminar to welcome Professor Diego Thomas. Professor Thomas is an associate professor at the Graduate School of Information Science and Electrical Engineering at Kyushu University. He received his master's degree in informatics and applied mathematics from the École nationale supérieure d'informatique et de mathématiques appliquées de Grenoble, so in France, in 2008. He received his PhD from the Graduate University for Advanced Studies, Sokendai, in Japan in 2012. And afterwards, after his PhD, he was a postdoc researcher at the National Institute of Informatics in Tokyo from April 2012 to March 2015. He was also, from April 2015 to March 2017, a JSPS postdoctoral researcher at the University of Kyushu. And then finally, before his current position, from April 2017 to November 2022, he was an assistant professor at the Graduate School of Information Science and Electrical Engineering. His research are mainly related to 3D vision and computer graphics, such as 3D and 4D capture, and also augmented reality, virtual reality, and digital humans. So with that being said, today he will present, based on his research interests and on his research work, the presentation on creating bridges between the digital and physical realms with 3D vision. Therefore, it is my great pleasure to welcome Professor Thomas, and I will now hand it over to him. So I hope you will all enjoy his presentation. And then afterwards, there will be a Q&A where you can post questions in English or in Japanese in the chat. So please, if you do have questions afterwards, you can post those in the chat in English or in Japanese. Thank you very much, Professor Thomas. Welcome, and please do start your presentation.
Hello, everyone. Thank you very much, Professor Schumacher, for the kind introduction. And thank you very much for all the organizers of the Brownback seminar to invite me to speak today. So I will share my screen now and start the presentation. Okay, so I think you should now be able to see my screen. All right, so hello everyone. So I'm Diego Thomas. I'm from the Department of Information Science and Electrical Engineering. And it is my pleasure today to talk to you about how computer vision, or more precisely how 3D vision can help to create better interactions between the digital worlds, so or we also say virtual worlds, and our physical world. And today I will start my presentations by showing this graph. And this is the only graph I'll be showing today. So this graph is showing the evolution of the GDP in the world per habitant over the last 200 years, right? And what we can see from this graph is that we have become very rich in the last 200 years, right? If we think about it, today in Japan, most people own a car, and the car can drive and can make the people move at 100 kilometers per hour, and this for hours. And also everyone has a smartphone with which you can communicate, we can talk and send videos to people at the opposite side of the world instantaneously, right? And these are things that 200 years ago, even kings could not dream about it. So what made us so rich? It's not that we became so much more intelligent than our ancestors. I think Mozart or Da Vinci were very pure geniuses, right? So what helped us to become so rich is the fact that we became able to extract and process fossil energy like petrol and gas. And this allowed us to create and power many machines, right? And today in our societies, we are using a lot of machines, which are kind of as many mechanical slaves that allows us to become so rich, right? And so, for example, today I came to work by using a machine. Now I'm talking to you by using a machine, and at lunch I will be eating foods that will be brought to me by machines, right? So today our societies are totally dependent on machines to survive, right? Big cities cannot survive without the machines. But all these machines, they eat petroleum, right? They use fossil resources to move around, right? And these fossil resources are finite, and at some point there will be no more. And some people say this time may come even quite soon. So for the future of societies, it is very important to think about how to create smarter machines, right? So machines that can be more efficient in the way they use the resources available, and machines who are also more efficient into helping us in the societies, right? So that it can help also to move societies to a better level. Right, so the question is today, how smart are these machines today? So I think many people now in your home, you have a very nice robot, which is called Roomba. And the Roomba robot, if you give a 2D map of your home, then the Roomba robots can clean up your room very efficiently, right? And this Roomba robot is working very well. It's very good. But now, if we ask a robot to do a very easy task in the 3D space, like, for example, just put a box in the shelf, then the robot totally fails, right? And this is a research results from one of the top research institute in the world on the robotics, right? And this totally fails. So why it fails is because the robot is lacking, it needs a more detailed understanding about its 3D environments, right? The robots need to understand where it is located. The robot needs to understand what are the objects around it and how to interact with the objects. And without this, the robot cannot evolve to another step. And if we look at humans, to understand our world, to interact with our worlds, our environments, then the human brain uses about 60% of the power is dedicated to vision, right? So it appears quite clear that vision is at the core and needs to be at the core of artificial intelligence to help these machines to better understand their surroundings and better interact with the real world. And without it, there is some gap between what we can do in the digital world and what we can do in the real world. So this is kind of a picture of today's. And on the bottom left, it's what's happening today in the digital world. And I think we can see today that there are a big revolution with artificial intelligence in the digital world, like ChatGPT, for example. And it has been said that ChatGPT passes all the tests that says it's intelligent, right? So we now have kind of very intelligent machines in the digital world, right? With very intelligent machines in the virtual world. But still, our machines in the real world, in the physical world, the machines we are using every day are still not so smart. Like if I use my car, at least if I close my eyes and let my car drive alone, then most probably my car will crash. Although it just had to go very straightforward. So still not very intelligent. And so there is a gap here between what machines can do in the virtual world and what they can do in the real world. And for tomorrow, in the future, now there is a lot of research that is pushing towards creating large vision models, or maybe I would say large 3D vision models. And these are needed, these are required to make this gap between the digital world and the real world smaller. And if we can have a good vision model, then the machines can understand how they can interact with the physical world, and then we can have maybe a next generation of smart machines to improve our societies. But to go there are several technical limitations, several problems that must be solved. And today I will talk a little bit about one of these problems. I will talk about digital humans, because machines are working for us, for the humans. So at first we want to see how we can model the humans in the machine so that the machines can better understand how they can help the humans. Okay, so before I start and dive into more specific research topics, let me briefly introduce about the role of computer vision. So the goal of computer vision is to make the computer see, right? But to make the computer see, it is not just about plugging a camera to the computer. If you plug a camera to the computer, it can capture an image, right? Like this image on the left side. But the human, we can see from this picture many things. We can see, for example, there is a woman, and the woman is playing shamisen, and this is very detailed information. But if you give this image to the computer without doing anything else, then the computer, what it sees is just a sequence of signals, color signals, just numbers that represent like the color at each pixel that make the image. And from this, there's nothing the computer can say. So what we need now is computer vision algorithms that will process the image and extract some information, right? That allows this computer to see things, right? So the computer vision algorithms, they will act like the brain for the computer. And in my research, so I am very much interested into how we can use computer vision algorithms to better understand humans, or to capture, to model, to represent the humans into the digital worlds. And this comes to the field of digital humans. And from now on, I will talk a bit how we can use computer vision or 3D visions to create and better model digital humans. And how to make digital humans, how to represent humans from images is a research topic that is here for a long time. And at first, the first thing you can do, if you are given an image of a person, you can think to represent the human by using a bounding box and label. For example, if you have these images, you can put a square around each of these persons and represent each of these humans with a box, and then put some labels, some text on each box that says this is a human. And this label can be more or less precise. It can say this is a woman, this is a man, this is human number 1, human number 2, etc. And even if it's very simplistic representation, still it is used a lot in many concrete applications. It's still very important technology. And this is something that we know how to do now, and it's a very mature technology, right? Even though it's still important for many applications, well, I think we can all agree that a human is not just a square bounding box, right? We are more than this. So another thing, to go one step further, another way is to think about the human as a skeleton. So you can represent the human using bones, and bones that are connected with each other by joints, right? And if you use these skeletons, then it allows to represent a human pose, right? Or human posture, right? And this is very important information for the human, because from the human posture, you can get a lot of information about what is happening in the image, okay? Like a posture gives a lot of information if somebody is thinking, if somebody is angry or happy. Gestures, for example, can also be a language, so it conveys a lot of information. And in some social events, in social environments, using the gesture, the pose is very important to convey the information, right? And so extracting the skeleton and understanding human pose from images, from 2D images, is a research topic that has been here for a long time. And the goal is given to the image is to find the location of all these joints that connect the bones together. And we can do it from a 2D image, but we can also do it for multiple images and then go to a 3D pose estimation, right? So we can have 2D pose estimation, but we can also have 3D pose estimations. And to do the 3D pose estimations, you can use some markers, but you can also use some multi-view systems, right? And this is also very interesting if you want to make applications for sports analysis, for example, if you want to do some robot manipulations, or to better help healthcare systems, for example. And so in the lab, we have tried to see how good is the state of the art for a 2D pose estimation. And we have seen that if we put sufficient effort into training techniques that already exist, into preparing some data, then we have seen that actually these 2D pose estimation techniques are working very well. And as you can see in this video, even though the person can be moving very quickly, he can have the head up and down, and still this is now something that is very robust. So I think now pose estimation is also coming to kind of maturity in terms of technology. But well, I think, so okay, the skeleton is also very good, but still it's not really what we are hoping for, right? Because humans are not just bones, we are flesh and bones, right? So the next step is to think about reconstructing the 3D shape of the person. So we want to have the flesh of the person. We want to reconstruct the 3D shape of the person. At first, research has focused into making the naked body, right? Because it's more easy, there is less variations. And to do it, we have in our dispositions a lot of templates, so models that have been created from data sets of almost naked people. And these are very useful. Even today in like cutting edge research, we are using these template models to better understand, get some understanding about what is happening into a scene, right? For pose estimation or for to generate some human shapes. Now this is good, but I would like to go even one step further. And in my research, what we are interested in is actually capturing the 3D shape of humans with clothes, right? Because in general, we do not walk outside naked. We are wearing clothes. So we want to capture the 3D shape of people with clothes. And we also want to capture the appearance of the persons and also motion of the persons. And when we are capturing shape and motion, then we are talking about 4D capture, right? So that's why in the lab, in the research, we are working on 3D and 4D captures and mostly focusing on the human body. So to do this, at first, almost 10 years ago, and there is this nice camera, which is called Kinect camera that appears, which is a depth sensors. So at the beginning, we have been using sensors to capture the 3D shape. And 5 years ago, what we worked on was to combine multiple cameras. So we used several Kinect cameras, and one camera has just a small field of view, but if you put multiple images, then you can capture a large scene, right? And by using multiple cameras, what we could do is to capture some motion of people interacting and playing games together. And also one fun side effect is that if you put these two Kinect cameras that look at the same position in the scene, because they're capturing images slightly at different times, we can actually improve the frame rate or the number of images that are captured per second, and then we can capture some 3D data with slow motion effects. So, which was quite interesting effects to see. So all these sensors are very interesting, but still for the human, the whole body was not so much detailed. So we further pushed onto reconstructing much as detailed as possible 3D models. I will stop this. So to do this, we focused on the face, and we tried to reconstruct detailed geometry of the face while tracking the person expressions, right? Because for the human, having detailed facial expressions is a lot of information. And we could do it for the face. And by that time, we tried to think about how we can go back to the whole body, so to model the whole person with the same level of details as we could go for the face. And at that time, there was a kind of a new revolution in our domain, which is called deep learning. And with deep learning, what we could do now is we realized that something that was thought to be impossible, which is get the geometry from just one image, is a problem that is imposed, right? Because if you just capture one image, then there are many possible combinations of geometry, color, lighting, viewpoints that could make the exact same image, right? So it's this reverse problem is imposed problem. But if we use deep learning and AI, actually, we found out there are some solutions that exist to do it. So basically, 3-4 years ago, we realized that we can do some 3D reconstructions without using these depth sensors. So we can actually do the reconstructions just by using normal cameras, by using multiple view cameras, right? And this is very interesting because everybody has a normal camera. So it makes these solutions, these 3D reconstruction solutions available to much more people. And so when we try to move to full body reconstruction, then we start to investigate how can we make a deep network, train deep neural networks to reconstruct a 3D shape given just a single image. And to do this, what we do is we capture some data, some training data, and these 3D data we can, there are some publicly available data sets, and sometimes we can also buy some data sets if we need to. And what we are using is actually a set of 3D scans of the person. So there is like a full 3D scan of a person and the corresponding images of this person from multiple viewpoints. And what the network is doing is it is learning to map one 2D image, one color image to one 3D shape, right? And we give many examples of mapping one 2D image, one 3D model. And once we train, we optimize this neural network to fit all these 3D models. Then after, we can give a new image that was not in the training data sets. And because these neural networks allows to interpolate and extrapolate the data they have seen during training, then very interestingly, what we can get is some quite accurate, some decent 3D model, even if we give an image that was not in the training data sets. And that was very interesting results, right? So given just one single image, then we can output a 3D shape of the person with the clothes that is very close to a kind of ground truth. All right, so that was very promising results. But in this case, so we have seen that, now with such techniques, if we have some 3D assets, we are able to learn to make some static avatars from image or videos or scans, right? And that was very good. But these 3D models we are creating, they are static, so they cannot move. And for applications in games, cinema, or applications in our concrete life, what we would like is to have these digital humans that can be moved, that can be controlled in some virtual environments, for example. And so there are some follow-up research that has been done, and that taking the video, try to reconstruct a dynamic avatar. So in this sense, it means that you reconstruct a 4D avatars, right? You reconstruct the 3D shape and the motion. And you have some very nice results with this, which is great. But the problem is that what you obtain is only the motion that was given in the input, right? And what we would like to do is to go one step further and create an avatar that can be animated, right? That can be where you can change the motion. And you want to change the motion, but you want to change the motion so that the folding of the clauses remains realistic. And to do this, it comes to a field of research which is called animatable avatar. And the research is now to map some 3D scans with input motion sequence and learn how to map a 3D pose, a skeleton, to a full 3D shape. And we have tried to do this in the lab. This year, we have proposed the methods which, by using some captured 3D scans, what we can do is train again a deep neural network that takes as inputs a skeleton, so a 3D pose, a motion, the pose, and the corresponding 3D scans with all the wrinkles in the clauses. And once we have trained this network with some example data, then the algorithm is able to generate new unseen pose, right? So you are given as input one motion, and the goal is to generate a new motion with also following some detailed clause deformations. And here is what we can obtain. So if you look at this, in green is input data. So you see there is some mapping pose, like a skeleton in some different poses, and the corresponding 3D scan, right? So there is a whole shape of the person with folding of the clauses. And we give this data to the algorithm, the network, and it's trained on the data. And once the algorithm is trained, then what we can do is give a new motion. And with the new motion on the right, you can see that we can reconstruct the full shape of the person in this totally new motion, right? And even though it is totally new motion, you can see there is still some folding and some realistic effects on the clauses. So that was also very interesting projects to do, and we can see that we can actually learn to make some animatable. We can learn to model the animation, the deformation of the human body from some data. All right, so with all these techniques and trials and experiments we have done in the lab, we can see now today that the 3D vision networks allow to generate some very precise and interesting models of digital humans by learning from 3D data sets, right? So this works very well if you are given as inputs some 3D data. And to get this 3D data, in general, what you have to do is to go to a 3D studio where there is a very precise equipment and multi-view cameras and sensors that capture your 3D shapes. And you need many people to go to the studio to make a big data sets. And if you have a big data set, then you can train these neural networks very efficiently. But there is one limitation in this approach, is that it's very expensive to make the data, and you cannot have a very huge. It takes time to generate this training data set. So there is a limitation that such model cannot scale to represent all the diversity of human beings. And so recently, now we are working into techniques that can learn to model the 3D shape of the persons without 3D supervision. So what we want in the future, and what is still ongoing research today, is now to achieve similar results, but without using these 3D data, but using only 2D images as supervision, more like humans are doing, right? So by using just videos, input videos, example of videos, so many viewpoints, how can we learn to extract these 3D shapes is now the current topics, cutting-edge topics in the fields and things we are working on. And if we can do it, then I think this will be one big step towards building large vision models, at least for representing digital humans. And this will be one big step for making smarter robots and smarter machines to help our societies, right? And so this research has many applications. So now we are collaborating with companies like Microsoft, and I think this is a key topic to advance to better understand our 3D worlds and to allow the machines to better understand our real world. And these are applications for autonomous vehicle, for example, or better healthcare systems. All right, so I think it's almost time. So I will conclude with this slide for my talk today. So I've shown a bit some results about what we are doing in the lab, but these are the take-home messages and things I would like you to remember from my talk today. And there are 3 points. And the first point is that, as I said in the beginning, our societies today totally depend on machines, right? So we depend a lot on machines. And so for the future, we are going to face energy crisis in more far or short term. And so we need to think quite quickly about how to deal with energy crisis, and making smarter machines is one can be one of the solutions, and smarter machines that can better help us, but also better use their energy. And to do this, to make smarter machines, what we need, what the Computer Vision Committee is doing, is advancing towards creating large vision models. And I would like to say large 3D vision models, right? And I think one very promising research now is to learn to make some modeling digital humans by looking at only images and videos. And recent research show very promising results in this direction, so I'm pretty optimistic we can make some very large, nice 3D vision models in the future. And the last thing is that machines work for humans. So although we want the machines to understand all the world in general, at the first step, I think it's crucial that the machine understand people, that the machine can understand humans. And for this, we are focusing our efforts on digital humans. And I believe that digital humans will be a first step towards closing or making this gap between the digital world and the real world smaller. All right, thank you so much for listening. And this is my last slides. And with these slides, I would like to end my presentation. So maybe I will stop sharing my screen and go back to Professor Schumacher. And I'm here. I'm very happy to answer any questions if you have some questions.
Thank you very much, Thomas Sensei. So for all the participants, if you do have any questions, be it directly related to presentation or like to this area where you think Professor Thomas's presentation might provide some, or he can provide some insights or answers, also about his slides or something, please do not hesitate to write your questions in English or in Japanese into the chat. So please do so if there's any questions. Where do you see, for example, this technology going? What are potential applications that you are wondering about? Are you afraid of AI? Is it something that you are concerned about? Or like recent developments in AI technology, like the huge leaps that have been done, for example, on text-based machine learning and ChatGPT? Or how do you see a link between ChatGPT and your research? So you can ask all questions to Professor Thomas if we will wait a bit, because I do have 1 or 2 questions that I would ask, but I first want to, all the participants, if you have any questions, please do not hesitate to write your question into the chat in English or in Japanese. So, okay, well, then to start it off, I would like to start and ask a question, and my last bit kind of gave it away, because you also talked about, your last sentence was AI or technology is meant to serve humans, and it is developed by humans. But do you see with the rapid leaps that, for example, text-based we do have questions, so I will first hand it over to those. First question is, how does the situation about applicate to analyze animal behavior? So, for example, if I might interpret, can this technology be used to, for example, monitor animal behavior rhythms?
Okay, right. Okay, thank you so much for the questions. And yeah, it's very interesting. So there is analyzing animals and reconstructing 3D models of animals is also very closely related to the core technologies here. And in the lab, we had some projects actually, which if you're given a video of a dog and how to make the 3D model of the dogs. And so it can be applied. So you just need to change a bit the networks, because the prior of the human skeleton changes. You need to have some priors for the animals. But there is very interesting applications, because even for the humans, we had some project recently and asked the students to stay still while we capture the data to make some experiments. And it was very difficult for the person to stay really still. And even for the person, it was difficult. So if you want to capture 3D data for a dog, for example, it's impossible to ask the dog to remain still for like 1 minute while you're turning around the animals, right? So for the animal, it's super important to be able to allow this kind of 4D capture when everything is a video, everything is moving, and still while you move around, you can still in the end reconstruct some 3D data from it. So I think there are very much connections between analyzing, reconstructing for the videos, people in motion, and this can also be applied for capturing animal motions and shape.
Then one more question. Professor Thomas, thank you very much for the presentation. So I can understand that we are using the 3D image to set up the basic motion and use algorithm to make the 3D model, or if motion is involved, I would even say the 4D model. Is that correct?
So there are different approaches. So the results I was showing with the animation, the animatable avatars, as the training data, we had 3D scans. So we were using both motion pose estimation from 2D images and also 3D data to refine the estimations. And so to make the 3D models, in general, we are starting from the 2D images, but then taking 2D models from different views and then do some kind of triangulation, right? If you see the same person from different views, you can get skeleton from different 2D images and merge these two views or multiple views 2D information into one 3D models or one 3D information. And we use these 3D information to supervise 3D model reconstruction, 4D model reconstructions.
I have a question, and there's one final question that I will also get back to later, but to what you just said. Do you think your technology can be used, for example, let's say someone has a very vague picture of a criminal that did something, but we only have one single picture, but we kind of know how tall, how tall they might be, if they're male or female or something like that. We might have some basic features. Can your technology be used to kind of create a 3D profile of someone who might fit that description in terms of from an existing database of, for example, motion and how people, for example, people who are 180 centimeters tall, how would they move versus someone who's only 160 centimeters tall, things like that. Would that in the future be possible to create such 3D images of, for example, a 3D profile of someone where we only have a very limited data background from with your technology?
Okay, so it's very interesting questions. And so technically, I would say there is maybe answer is not so straightforward. So basically today, if you're given some features, some information about a person, we can use and we can use already you can use some kind of ChatGPT AI to make 2D images of the persons, and I believe it's just a matter of time before we can use a 3D model of this person by just having some kind of key features, right? But this will be AI generated images, so we can make a 3D model or 2D image of somebody that looks very realistic, and that looks very nice. But can we use it as forensics, as evidence for to find some bad person or in trial? Then that's totally different question, because it can look very realistic, but in the same time it can be totally different than the real person. So it will generate some data, but is this data true or not? This is a totally different question. And same as what we see a bit with ChatGPT, that ChatGPT can create some story, can create some images that looks very new, very nice, can give you some explanation about things that sounds very good. But if you look into details, actually there was some totally misunderstanding somewhere. So I think in the near future, we can use AI to create some nice 3D models of people, and we can kind of tune up what kind of people we want to generate. But I don't think we can use them as evidence for finding a bad person, to identify a bad person to use in kind of a trial for the justice.
Very interesting topic, and definitely something that needs, or like, more research needs to be done also, and monitoring in the future. But a final question, or two questions, but I hope I will first get to the one, and then if we still have time, can also add. But in terms of sustainability, like in terms of the term of sustainability, how does your technology, or what could be, for example, in terms of energy consumption, in order to generate these images? Someone asks, what is the sustainability or the energy consumption profile of this like modern technology versus more traditional, maybe less technology intensive methods that still achieve reasonable results, versus the benefits and the trade-offs in terms of energy consumption, in terms of sustainability?
Okay, thank you. That's very interesting question. It's a good question, something that we need to think more about it. I think in the communities now, it was mostly pushing towards doing some achieving results that nobody could do so far, but I think now it's coming a bit. And as you say, like these deep neural networks is very interesting, but we need to train these models by using heavy computations on what's called GPU, like graphical processing units. That was machine that was used to make video games, to render the video games. And now we are heavily using these GPUs to train the networks. And I don't know how much for OpenAI to keep up training these large models on ChatGPT. It uses so much energy, and so I think the current models now are not sustainable, honestly. But I think people are now aware about it, and there are a lot of efforts that now try to achieve similar results by using less amount of resources. So it means instead of using like 10 GPUs, try to achieve the same thing with just using 1 GPU. And we can see more and more techniques that really speed up training time. So if you speed up training time, it means you're using a lot less energy, and there is like significant improvement. Like today, in one year, like to make this 3D model to train a network, it went from like 10 hours training to like 5 minutes. So this is kind of the gap we could do in 1 year, and this is moving so fast. So it's difficult to predict what will happen, but I guess in the future, maybe this with this training time will come much faster and maybe use less resources. And so today, I would say like maybe using depth camera uses less amount of energy, but in the future, maybe the AI-based solutions we kind of slowly, how to say, go back to same amount of energy, but with better quality, I guess.
Thank you very much. We're almost at the end. I just want to go very quickly in the last question because it kind of feeds into the question that I had. So, and with that, this will be the last question. So, are there any potential ethics conflicts or ethics considerations, ethics issues that you see on the horizon as this technology matures? Could it be potentially abused? Because everything can be used for positive purposes, but also can be abused, and then we need to act accordingly to minimize the abuse. But what are some of the ethical issues that you see in the horizon within your community, within your research community? What are some of the things that are being discussed? And what are some of the things other than regulation that can be done to address it? Because we saw now in ChatGPT, it playing out versus the financial profitability versus the ethics considerations, which was in a battle for the CEO position. So do we have similar issues? Do you see similar problems that it could be abused potentially?
So, okay, thank you. Yeah. So as you said, I totally agree. Any technology can be abused to do some bad things. So I think ethics in science is extremely important. It should always be thought about ethics. And I think that it would be good if there would be some, how to say, people specialized in ethics in the philosophical questions who would really take the time to think about it. Now, I think maybe one problem is that one difficulty is that technology is moving so fast. It's difficult to keep up just by going on the technological side, right? So we don't have so much time. We always think about it, but we don't have time to go much deeper, and maybe we don't have the expertise of like philosophical person. So I think it's important to have some people that take the time to really think more deeply into philosophical meaning about AI in general. And so, yeah, I hope people come up with some more deeper discussion about this. And for what I can see from now, one danger is that AI becomes very good to make some realistic looking images or 3D models, like as I said before.
You mean like deepfakes?
Deepfakes, yeah. So deepfakes are the most the biggest danger, I think, now in these things. And how do we deal with deepfakes? How can we detect deepfakes? And how deepfakes in the 3D data can be harmful for our societies is something that needs to be maybe discussed more deeply.
One at the end, as a conclusion, one might be a digital watermark for any 3D model, as it's already with some documentation, it requires a watermark or something that cannot be removed. So, or that might be one of the very few, in my opinion, sensible applications of blockchain technology, that every 3D model needs to have a unique identifier once it's put out, so that you can always track it and trace it. So that would be something where I see blockchain and AI working hand in hand together in order to improve safety and also avoid deepfakes, because every 3D model that is put out there might be able to be traced in some form or shape. So, but that is just my view. You are the expert, so we are looking forward to what you will come up and what your research will look like in the future. But thank you very much for today. There were a lot of questions, so we went a little bit over time, but that is a good sign. This is definitely a topic that is of very high contemporary interest. So thank you very much once again. And if you do have questions, I'm sure Professor Thomas will also welcome any questions that if you reach out to him and have further questions or further interests in this topic. So with that being said, thank you once again to everyone who joined, and also especially Professor Thomas. And then we will welcome you for the next Brown Bag seminar in a week's time. Thank you very much again. And thank you, Professor Thomas, for today, for your time.
Thank you very much. Goodbye.
ディエゴ先生、シューマッハ先生、ありがとうございました。最後に事務局よりご案内させていただきます。まず、次回のブラウンバックセミナーのご案内です。次回は来週11月29日水曜日12時10分より、九州大学芸術工学研究院の長津雄一郎准教授より、障害から始まるアート・ケアの場の創造と題し、講演を実施いたします。詳細はホームページをご覧ください。